بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. Yes. We discussed 3 theories so far. The first theory is called valence bond theory. Or actually, before valence bond theory even, we discussed the valence we discussed this. What's this? VSEPR. Hello. يا شباب.
ايوه
تسمعوني؟
ايوه واضح.
ايوه نسمع دكتور.
طيب. First thing we discussed actually was valence shell electron pair repulsion model, in which we have the shape of the structure, shape of electron domain, and shape of molecule. And then this was first model we discussed. Then we talked about valence bond theory. Valence bond theory says that the rooms are, if they are filled with electrons, unpaired electrons like this, then when the bond takes place, when the hydrogen come to the P, the electron of the hydrogen will come and will be shared like this, and we will make the bond by actually sharing the electrons in the room like this. And this way, we're going to have a bond between the sulfur and hydrogen in here, sulfur and hydrogen in here, by sharing the black electron is coming from the atom, from the sulfur, and the red electrons is coming from what?
The hydrogen.
The hydrogen, and will make the bond. And we know that the angle between the p orbitals is what? About, or what's the angle between p orbital? If this is px and py, what's the angle between them?
90.
90. And if the hydrogen comes and bond like this and bond like this, what do you expect the angle to be?
Closer to 90.
Hydrogen, sulfur, hydrogen. What's the bond is going to be? About?
Above 90.
About 90. Okay? Greater than 90. It was actually found to be 92. Okay? Then this theory was developed by using what's called hybridization. Hybridization of S and P orbitals. Hybridization means mixing. The new theory, which we discussed yesterday, says that actually before the bonding, there will be the order, depending on the electron domain. If the electron domain A, B, N, E, M, which we discussed yesterday, it depends on N plus M. If it is 2 or 3 or 4 or 5 or 6, this hybridization says that there will be mixing of orbitals before or when the bond takes place. If we have 2 only mix, then S would mix with P to make sp hybridized orbital. If it's 3, it's going to be what?
sp2.
How about 4?
sp3.
How about 5?
sp3d.
And 6?
sp3 d2.
D2. And the shape of this new orbital is similar to the shape of electron domain. which is if it's sp, then it will be linear. If it's sp2, it will be trigonal planar. If it's sp3, it will be tetrahedral. If it's sp3d, it will be trigonal bipyramid. And if it's sp3d2, it will be octahedral. You must know this, and you must know how the bond takes place. Then after that, we have another theory. Now, this is very important. We said that if we have two types of bonding, we have what's called this one and this one. What's the name of the first one?
Sigma.
Sigma. Sigma. Sigma. And what's the property of the sigma? How does it take place? If it is what?
It's head to head.
Head to head or
End to end. End to end.
Okay. How about bi?
Side to side.
Side to side. Or face to
Side or
Face to face.
face to face. Exactly. All right. And this one take place, for example, if P mixed with S, is it going to be sigma or bi?
Sig.
Sigma. Sigma. All right. How about if we have P with P?
Sigma also.
Also sigma. This is sigma and this is sigma. When are we going to see bi?
When it's side to side.
Like this. This is bi. Okay. And then I told you also, if we have any elements, if there is only one line, this means this is what?
Sigma.
First line is sigma. If we have two lines, one of them is
Sigma.
Sigma, one of them is bi.
bi. If we have three lines,
one sigma to y.
you must keep this in mind. And that's when we give you organic compound like this, the thing that we don't write is actually carbon. So anything is not written here is actually carbon. Okay, now I'll ask you a very simple question. How many O by bond?
21.
O by bond. Only by bond.
5.
Where is O? No, sorry. No,
There's no. Oh.
no, sorry.
Carbon.
Carbon. Oh. CO by bond. How many?
4.
4. How about CO sigma bond?
Also 4.
Also 4. How about CN sigma?
4.
4.
No.
5.
5.
5. How about CN bi?
0.
0.
0.
Zero.
0, exactly. How about CE sigma?
12.
12.
How about CC bi?
3.
3.
3.
You should know this, and you should be able to find all this information. Next, after that, we have another theory. This is another theory, completely different theory. It's called molecular orbital theory. Molecular orbital theory. We sometimes refer to it as MO theory, but rarely. We call it molecular orbital theory. This theory is different from the valence bond theory or the bonding theory. In this case, this theory says, for hydrogen, for example, if we have hydrogen H2 molecule, if we have the hydrogen atom, which is, this is the hydrogen atom with one S and one electron. And the other hydrogen atom is one S and one electron. When these two orbitals mix together, they make new two orbitals for the molecule, one at lower energy and one at higher energy. The one at lower energy is called sigma, and the one at higher energy is called sigma star. Or it's called, this one is called sigma bonding, sigma bonding, and this one is called sigma anti-bonding. What's the meaning of anti?
مضاد.
Against.
مضاد.
Against.
بالضبط. sigma star مضاد للbonding. All right. And then when the two atoms comes together, the electrons are distributed to the lower orbitals. So the two electrons will come here. And then to count the bond order, you must memorize the name, bond order, which is the number of bonds. But the bond order, it is actually, what is bond order equal to? It is equal to electrons in bonding minus electron in anti-bonding divided by 2. So what's the bond order? Bond order for H2 molecule. How many electrons do you have in bonding?
2.
2. And how many in anti-bonding?
0.
0. Divide by what?
2.
2.
2. What's the bond order?
1.
1. Fantastic. Let's talk about other molecules. Let's talk about H2 plus. When we make H2 plus, this means what did we do?
Remove an electron.
Remove electron. Then how many electrons will be in bonding?
0.
1.
No. 1. And how many in anti-bonding?
0.
Yes, divide by 2, which is equal to what?
Half.
Very good. Now, let's talk about H2.
From where I can know the anti-bonding, the electron anti-bonding.
Let's do this one. If we have H2 minus, how many electrons in bonding? But how many electrons we have total? H2 minus.
3.
3.
How many electrons will be in bonding?
2.
2.
And how many in anti-bonding?
1.
1.
Yes, because we have 3. I already put 2 here. I would the third one here. So it will be 2 minus 1 divided by 2, which is equal to what?
1/2.
Again, 1. Is this clear? Is this clear? Okay, good. Next, let me ask you a very simple question. Which is having a stronger bond? H2 or H2 plus?
H2.
Why?
It has higher bond order.
Exactly. Okay, which one is shorter, H2 or H2 plus?
H2 plus.
No,
Also H2.
it's also H2. Why? The stronger the bond, the shorter the bond. The stronger means very strong attraction. Is this clear? Very good. Now, let me ask you about H2 and H2 minus. Which one having stronger bond?
H2.
H2.
Which one having shorter bond?
H2 also.
Also H2. Very good. Let's have He2 molecule. Can we make this molecule? What's the bond order for He2 molecule?
Four.
Give me numbers. How many in bonding?
2.
And how many in anti-bonding?
0.
No, how many total electrons you have?
2.
How many total electrons you have for helium? For 2 helium?
4.
4. We have 2 in bonding, and how many in anti-bonding?
2.
2 divided by 2 is equal to what?
0.
2.
So how many
Zero.
bonds are there between He and He? No bond.
Oh,
That's why it does not exist.
So, doctor, we cannot have a.
He2 molecule.
Yes.
Okay. How about He2 plus? Can we have it?
Yes.
What will be the bond order?
Half.
2.
1
Two.
minus
Minus
2.
What?
1.
Minus 1.
That's 1 divided by 2, which is equal to 0.5 or half. Clear? So we can make this molecule. Good. This is for hydrogen and helium. Now, I want to define 2 things here. I want you to write these names and memorize it. Paramagnetic and diamagnetic. Paramagnetic and diamagnetic. What's paramagnetic means? And what's diamagnetic? Diamagnetic, if you have the rooms, all the rooms, if you have many rooms, let's have this one and this one and some other rooms. If all the rooms have 2 electrons, or of course empty, then if everything have 2 electrons, then this is called diamagnetic. Diamagnetic. And it's not attracted to the magnet. If there is any electron by itself in this room, or for example, if we have any room, like for example, if we have this, and we have 1, 2, and 3, let's say like this. All right, then this molecule, if it's a molecule like this, or this molecule, this is called paramagnetic. And paramagnetic means it's attracted to the magnet. It will be attracted to the magnet. All right? Okay. What's para and diamagnetic? Let's go back to hydrogen and let's see now. H2 molecule. H2 molecule. Is it going to be paramagnetic or diamagnetic? H2.
Para.
Dia.
Die.
Why?
Because 1 is 2.
Because there is 2 electrons in sigma. 2 electrons in sigma and nothing there. How about H2 plus?
Para.
Paramagnetic.
Why?
Because 1 electron. 1 electron in sigma.
How about H2 minus?
Para.
Both.
Why?
1 electron.
Ah,
in-
not both. The person who says both wrong. You cannot say it's both. It's either diamagnetic or paramagnetic. This one is para. Why? Because there is 2 electrons in sigma and 1 electron is in sigma star. This means there is 1 room in the whole molecule which has only 1 electron. This means it's para. How about He2 plus? Is it para or dia?
Para.
Para also.
Para.
Para, yes. Is this clear? I hope this is clear. Now, next. If we have this, if we have oxygen, this is oxygen and this is the magnet. If we use the valence bond theory, all right, we find that all the electrons here, look at the electrons. All the electrons are paired according to the electrons which are paired. Is this going to be paramagnetic or diamagnetic?
Magnetic.
Para or dia? Come on, I need answer.
Dia.
Diamagnetic.
This dia, according to this structure. Why?
2 electrons in this sigma.
Each 2 electrons are together. 2, 2, 2, 2, and 2, and 2. Everything is together, so it should be diamagnetic.
Yes.
But in experiment, it was found, this is magnet now, and it was found that it is paramagnetic. It's affected by the magnet. See, the oxygen is going this way toward the magnet. So it is actually paramagnetic. Okay, and this is explained by molecular orbital theory. This is the explanation of valence bond, which does not exist, but this one is the right exception. We will explain how this one is paramagnetic using this theory. Now, in here, we know that, we already talked about this. Now, we know that if we have S and S, they will interact with each other to make what?
Sigma bond.
And sigma star. Sigma and sigma star. When we have P with P, if they are connected like this, what type of bond is this?
Sigma.
This is sigma. This is sigma. All right. Again, it's sigma. And it will give us this shape, which is the dark blue. Dark blue is the sigma. And it will make sigma star, which is the blue. This is this one and this one. They're not two, but they're one thing like this one, and this will be the sigma star. These together, like this is the sigma star. All right. But the other p orbital, this one with this one, how are they going to interact? By sigma or by?
By.
By. And this one and this one, I'll put line like this so that I connect them. How are they going to interact?
By.
Also by. So we have how many, and by how many orbitals we have?
2.
What?
2 pi orbitals.
2 pi orbitals, exactly. And this is the sigma, and this is the sigma star. Sigma 2p, this comes from the 2p, and this is sigma 2p star. This is the shape. And the p orbital, when they mix together, they will make 2 orbitals. This is the one which will make bonding, and this is the anti-bonding. All right, and this is the shape of this orbital, and this is the other pz orbital, which is like this and like this, which will make the bonding and anti-bonding, or we can mix them together like this. And this is how we make them. Now, the most important thing in this slide, I want you to memorize this extremely well. This is the orbital that when we have 2 atoms mixed together, 2 atoms mixed together. If we have lithium or B2 or C2 or N2, then we will have this order. If we have O2 and F2, we're going to have this order. Order A and B. What's the difference between them? They are exactly the same, except these 2 orbitals are, what happened to them?
Switch.
Them. What?
Switch.
Switched. Exactly. Flipped. One up and one down. So if I ask you to write this structure for C2, you should use the structure B. If I ask you to do it for O2 or F2, you should use structure A. How about if I use OF? Which one I use? I also use A. But if I use CO, which one I'm going to use? I'm going to use B. All right. And how about if I use NO? I'm also going to be using B. Now, I want you the shape, and I want you to know the order. You must memorize this order, and you should be able to write it sigma 2s, sigma 2s star, and then pi 2p, and then sigma 2p, and then pi 2p star, and then sigma 2p star. I want you to memorize this shape very well. This is for structure A or B? A or B?
B.
B. How about if I ask you to write A? What are you going to write?
Sigma 2S.
Sigma 2s.
Sigma 2s.
My star 2s.
R, and then
Sigma 2p.
sigma 2p, and then
Pi 2p.
pi 2p, and then
Pi star 2p.
then sigma 2p star. You must memorize these 2 structures. Memorize them very, very well. Next, I'll talk to you in a while, just a second. Now, if I have a B2 molecule, or let's start with C2 molecule, C2 molecule, okay? And I want to know what's the shape of the C2 molecule. How many electrons do I have in the valence of carbon?
4.
4.
How about I have 2 carbon? This means a total of what?
8.
8. Where am I going to put these 8 electrons? 1, 2, 3, 4, 5, 6, 7, 8. Is this clear?
Yes.
Now,
Okay.
done. Now, you can write it this way, or you can write it just simply sigma 2s 2 sigma 2s star 2, and then by 2p what? 2? 4. There are 4 electrons here. 4 electrons. Okay. My first question, is this diamagnetic or paramagnetic?
Die.
Die.
Why dia?
Every two
All row have
electrons is bond.
electron.
4 electrons are paired. Very good. Next, what's the bond order?
Three. 6 minus 0 over 2.
6 minus 0?
Oh, 8.
6 minus
8.
No. What's the bond order? It's bonding minus anti-bonding. This is bonding. This is bonding, but this one is anti-bonding. When you see the star, it means anti-bonding.
Oh,
And
6
then
minus 2.
it's 6 minus 2 divided by 2, which is equal to what?
2.
2. Excellent. All right. Very good. Let's do it for something else. Let's do it for B2 molecule. Very quickly. B2 molecule. What's the total electrons?
6.
6. Okay, how are you going to distribute them?
Sigma is 2.
Yes.
Sigma 2 is star.
Yes.
Pi 2p2.
Excellent. Yes. Now, is this diamagnetic or paramagnetic?
Bar.
Paramagnetic.
Why?
There is 2 electrons who are not paired.
Electron. 2 unpaired. 2 unpaired electrons. Exactly. What's the bond order?
4 minus 2 over 2.
4 minus 2 over 2, which is equal to what?
Half.
1.
1.
Okay. Can we do it for NO or, yeah, NO minus? Okay. How many electrons you have for nitrogen? Valence.
5.
5.
And oxygen.
6.
6.
And then we have 1 extra electron for the minus. Total of what?
12.
12.
12.
Distribute them very quickly. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's the bond order?
Sigma S 2S2.
8 minus 4.
All right, first 8 minus
4.
4 divided by
2.
2.
2, and the answer is
2.
2. Yes. Is it paramagnetic or diamagnetic?
Para.
Why?
2 unpaired electrons.
Exactly, it's para. Very good. Now let's do it for O2. How many electrons do you have for O2?
6.
12. Which shape I'm going to use, A or B?
A.
Yeah, now I have to use A. Okay, distribute the 12 quickly. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's the bond order?
2.
Give me numbers first.
8 minus 4.
8 minus 4.
8 minus 4 divided by 2, which is equal to what?
2.
2.
Is this para or dia?
Paramagnetic.
Paramagnetic. This explains So it is according to molecular orbital theory. O2 is paramagnetic, not like valence bond says it is diamagnetic. And that's why this theory is better than the valence bond. Good? Next, let me ask you a simple question. Still here. Now, I want you to tell me what's the bond order for O2 plus? Bond order, quickly. O2 plus means what? We took how many electrons?
1 electron.
11.
Okay, so we have 11. This means we lost 1 electron. What will be the bond order? Quickly.
8 minus 3.
Yes.
Which is equal to what?
5 over 2.
5 over 2.
Okay. How about O2 minus?
9. 8
10.
minus 5.
8 minus
5.
5. Divide by
2.
2, which is equal to what?
1.5.
So if I give you 3 molecules, O2, O2 plus, O2 minus, which one will have the strongest bond?
O2 plus.
O2 plus.
Which one will have the shortest bond?
O2 plus.
Which will have the weakest bond?
O2 minus.
O2 minus.
O2 minus. Which one will be the longest bond?
O2.
O2 minus.
I hope this is clear. And now I'm not going to give you this diagram in the exam. I will give you only, or I will ask you to write this diagram in the multiple choice or whatever. I'm not going to give you this diagram. That's why I want you to memorize this extremely well. And you can imagine, you can put the boxes in your mind, but you have to memorize this order, A and B. A is for O2 and F2 or OF, but B for anything else. If you have C2, N2, B2, or even CO or NO, use always B. Is this clear?
So what about other elements?
Only we're going to talk about these elements. Only.
Okay.
All right. Only, and we're going to talk about only 2 atoms together, not even more than that. So we need to know, I want you to memorize this extremely, extremely well and keep it in your mind. That's all what we need to know from this chapter, from this section. Is this clear? Do you have any question? Good. Now, let's go to, yes, let's do this. The superoxide, O2 minus. O2 minus. What's the bond order? You have to write.
8 minus.
Yeah, write the structure. Tell me what to write. Sigma.
Sigma to S2.
Sigma to S2, and then
Sigma star to S2.
sigma to S star 2, and then sigma
to
P to
4.
to P2.
And then
Pi
to
to
P4, and then
By
pi
star.
sigma
pi 2p
Star.
star.
How many electrons?
2. No. 3.
1
3. You should be in the exam able to write this. You should know how to write this. I wrote it for you here, but you should be able to write it yourself. Is this clear? Now, what's the bond order?
8
minus 5
over 2.
by 2.
Is equal to what?
1.5.
1.5.
or 3 over 2. Clear? You should know this yourself. And that's the shape that you're supposed to have. But as I said, I'm not going to give you this in the exam. You should know it by yourself. Yes?
What is the numbers above the pi and sigma?
Name the number.
The 2 and 4 and 3.
These are the electrons. We have, how many electrons we have? The valence of oxygen, 6. 2 oxygen, 12 times 2 is 12. Plus 1 electron, this is 13. We distribute the 13. We put 2 here, 2 here, that's 4, plus 2, 6, plus 4, 10, and 3 are left. And that's why we put them in the diagram. That's 2, and then 2, and then 2, and then 4, and then 3. This is exactly like what I read. 2, 2, 2, 4, 3. 2, 2, 2, 4, 3. These are the electrons.
Yes,
Okay.
thank you.
All right. Now, last thing I want to talk about is actually this shape. Let's talk about this shape. If I put here 1, 2, and 3. What do you mean by 1, 2, and 3? I mean the bond. If we have 1, 2, and 3, okay, which one is the shortest bond? 1 or 2 or 3? 1. Why?
This is
Strongest.
Because
Because
it's double.
Yeah, 2 and 3 are single bond. صح؟
But
وإيش؟
هذا الرنين صح؟
Eh, that's just resonance. Okay, I will
Yes.
keep something. I will keep this as 1, 2, same order, 3. If we go to the shape, this shape, which one is the strongest bond now?
2.
2.
2.
No.
How about if we go here? This is 1, 2, and this is 3. Which one is the shortest?
Okay.
3.
Okay. Now خلونا نقول إذا شفت الثلاث الأشكال مع بعض, which one is the shortest? 1 or 2 or 3?
The same.
They are the same.
Okay.
The same compound.
لا, it's not the same. It's the same compound, but they are using now a word which is called delocalization. I want you to memorize this word, delocalization. ايش معنى local؟
موقع.
محلي. صح؟ ايش معنى دي؟ دائما لما تجي دي ايش معناتها؟
ثنائي أو ثلاثي.
لا،
ثنائي.
داية ثنائي. دي نفي.
نفي.
نفي يعني غير محلي. delocalize يعني غير محلي.
يعني not explosive.
Actually, how are we looking at this bond? We will keep the sigma bond. Okay? بس الباي بوند انتوا قلتوا لي الان هل هي الباي بوند موجود في 1 أو 2 أو في 3؟ وين الباي بوند؟ Is it in 1 or 2 or 3?
None.
Any of them.
Where is it actually? It's all over them. That's why I will draw this bond like this, and they will say it is distributed in the whole molecule. And this way, it will be distributed among the whole molecule. It will be delocalized. The pi bond is what? Delocalize. ايش معنى delocalized? It does not have a certain place. It's all over. غير ما لها محل معين. ما غير محلي. It's not in a place. It's all over. وبكذا لو أخذنا الرابطة 1 أو 2 أو 3 كم تتوقعون قوة رابطة 1 أو 2 البوند أوردر حق 1 أو 2 أو 3 كم حتكون؟
The same.
The same.
حتكون قيمتها
Equal.
1 and 1/3. Why I say 1 and 1/3? The sigma is 1. And what did I do with the pi?
You distribute it equally.
On all of them to make it delocalized. Is this clear? Is this clear?
Yes.
Okay, good. With this, we finish the chapter. And let's now go to the attendance, please. So I'll open the attendance. Okay. Yes. Just I'll open it, accept responses, and then